Colton Morgan.
What?
Amber is going to come do the warm-up for us. Thank you, ma'am. All right, probability we pick a Democrat, 0.6. Probability we pick a female, 0.17. Probability we pick a female Democrat, 0.13. And then female or Democrat. Most of you had 64 out of 100, but I picked Amber because she actually showed the addition rule we learned last time, where you add the probability of female plus the probability of Democrat minus the overlap. Yes, sir.
Do you want us to do the decimal thing too?
Yeah, okay. Probability, remember, lives between 0 and 1.
Oh, facts on that.
Oh.
We should turn the lights back to where they were.
Don't.
In a little bit. Alright, so today we're going to learn another new rule about conditional probability. And to help us do that, we're going to play a little card game.
I love cards.
Okay, well, I'll start with you then.
Yes.
Were you lying to me, Maggie?
Yeah.
It says, suppose I have 5 cards, but let's not suppose. I have 5 cards. Look at them.
I suppose you do.
2 of them are aces. Hey, look. 2 of them are aces. We're going to select 2 cards total, 1 at a time. We're going to find the probability of drawing 2 aces. So event A is the first card is an ace. Event B is the second card is an ace. All right, I'm going to mix them up. Don't look.
Okay.
What's the probability Maggie's going to pick an ace?
2 out of 6. 2 out of 6. There's 2 aces.
And where did 6 come from?
5. Sorry.
2 out of 5. So the probability that Maggie picks an ace is 2 out of 5. All right.
Okay.
That was a bad 5. Sorry. You ready, Maggie?
Yep.
6 equals a 4.
What'd you get?
A 7.
Ah, loser.
Basically.
Who else wants to play? Okay. Since it's your birthday tomorrow, okay?
It's not his birthday yet.
Tomorrow.
Feeling lucky.
I said since it's your birthday tomorrow. You ready? What's the probability he gets an ace?
Yes.
2 out of 5.
Low kiss.
Wow. Loser.
Wow.
Who else wants to play?
You were not looking.
Anybody else want to play?
I will.
I should have actually kissed her head.
Alright. What's the probability Katiara picks an ace?
2 out of 5. 7.
Dude.
No.
Wow. So that's 3. So that means the next one has to be.
Okay, this is.
And the next one.
Unless you mark something.
I got one on my sleeve at all times.
You know, as any kid, I can totally see you being that kid. What's the probability he gets an ace?
So this one's different, actually, because I'm built different.
Dude, Amber
This
looks
one, I
like
wanna go
Alright. Yeah, there are aces in there. I don't know.
I
Okay,
got
last time. Because, well, actually, I kind of need somebody to pick an ace. Usually it doesn't take this long.
we just have awful luck.
You should let me do it again.
What's the probability that Caleb...
Cheater.
gets an ace.
2 out of 5.
2 out of 5.
No.
Good
Oh,
job,
my.
Caleb!
Holy smokes.
Okay,
She cheated for me.
I did. I needed somebody to pick an ace. Because
That's
we
convenience.
need-
That's a convenience sample.
Don't
just
use
manipulated this.
statistics against me. Come on.
You manipulated this probability.
I was waiting for somebody to say 100%.
Right.
Said what?
When I said, what's the probability he gets an ace?
Oh.
Because I told him where it was. Alright, so Caleb picked an ace. Now we're going to see if he really can win the game because he has to pick 2 aces. I put the card back in. What's the probability he picks an ace?
2 out of 5.
2 out of 5. No, I didn't tell him where it is this time.
What the heck?
You guys are not good at this game.
No, don't worry, I can do it. I can do it.
I'm actually lost.
Nobody won.
This wheel just took a dump.
Alright. So, notice that when Caleb got the ace the first time, I put the card back in. That's called replacement. Now we're going to play the game without replacement. Maybe one of you can win.
I got it.
Alright. Oh, you both already tried, so I'm going to let Trey try. Okay. What's the probability that Trey picks an ace? 2 out of 5. Stop cheating.
Oh, I thought that was an ace. That's 4.
I think you need your
Easy mistake to
prescription
make,
checked.
Trey.
You thought that was
They're fake glasses as well.
They are fake glasses. Who has not played that would like to play?
I got this.
Alright, what's the probability Brooke picks an
Careful
ace?
this one. Those
Probability she
cards.
takes 2 cards because she's
Oh,
so
tell me
big.
there's protein in there. She's cheated.
Bro, one day you're actually going to make me insecure.
What's the probability she gets an ace?
Protein.
2 out of
0.
Okay, anybody else?
Me.
You already played.
Okay. Yeah, but just have to change the.
2 out of 3. 2 out of 3.
2 out of 5.
I thought we weren't replacing.
Here I have to say who wins. That is difficult. No,
Bro, the
James,
Christmas
you already
today
played.
is so cute. I love the sheep. I got an A.
Good job, Aster got an ace. And guess what, Caleb? I didn't even have to tell Aster which card to pick.
I guess Aster's just special.
Without replacement. So I'm going to keep the ace out. What's the probability that Aster picks
1 out of
another
4.
ace?
25% chance.
1 out of 4.
Shut up. Sorry.
You got the answer right.
Shut the fuck
Oh, Aster is good. Okay, what's your favorite candy?
Too good.
Well, how am I supposed to bring you a prize? Snickers.
Who picks Snickers?
What's the date today?
Did you say whose favorite candy has chocolate?
You're just trying to find record argument.
What do you mean?
Chocolate. I know that's the
What level are you
point.
on?
All right.
Chocolate and
37.
objectively based.
Mason, clear up. All right. Aster had a 2 out of 5 chance to get the first ace, which Aster did without me telling. I kept it out without replacement, so I didn't put the ace back. That changed our probability to 1 in 4.
Thank you.
Oh, sorry.
Answer's 2.
No. It's always 12.
Oh.
She's here.
2?
Thank you. All right. So this was an example of a conditional probability. The definition, Maggie, of conditional probability is the probability that one event happens, given that another event is already known to have happened, is called a conditional probability.
Wait, that doesn't make sense.
So with the aces, this probability here that Aster picked the second ace changed based on knowing that she picked the first ace.
Okay.
That would be a conditional probability. So suppose that we know that event A has happened, Aster drew the first ace, then the probability that event B happens given A has happened is written by P of B given A. And yes, when I say given, it's literally just a straight line in between them. So, excuse me, we're going to work with our deck of cards still, and we're going to focus on those two events we did last time, a jack and a red card. Everybody okay if I move it up? Colton? Do I need to move you? Okay. Alright, so we have our standard deck of playing cards. We're going to deal one card. We have our two events. J was getting a jack. And R is getting a red card.
What are the chances of
Eddie Bauer. Construct a two-way table that describes the sample space in terms of events J and R. Yes, we already made this two-way table the other day, but I want to see if you guys can create it on your own. Well, you can't because you weren't here. But Maggie and Colton should be able to do this on their own because they were here the other day. Create the two-way table for jack and red card.
So we do 52.
Hey, Leo, I went to the gym this morning and I didn't bring other shoes. Got my on clouds. What running shoes do you use?
Brooks. Why don't you help her? Because she wasn't here the other day. Teach her what a two-way table
Use
is.
Brooks.
Two-way table is like
What's wrong with Brooks?
I got on clouds.
you should look like
That's stupid. Do your work.
Thank you.
Boom. How do I make a table?
like shit.
My turn.
What? Categories.
Uh-huh.
R1 and R2.
That?
Trey,
I'm just trying to see.
pull out your notes from last class because we made this last time.
What's C mean?
C means compliment, not
Oh, we don't have
happening.
Oh, I don't know.
What is this little?
It's J complement, so that's not like that.
Okay.
If you forgot, Aster's going to help you out here again. Aster's very lucky today. Won the card game, going to the board. I don't know if Aster thinks going to the board's lucky, but
There's like, there's two red jacks. And then the rest of the cards, there's 26 total. There's two, 24, 26. And this guy's this
So there's 26 total red cards?
Aster, we can't see shit.
Just wait until I'm done.
Uh,
Just
yeah.
wait until I'm done. It'll be fine.
Can't see stuff. Can't see the board. That's all. There's a lot of substitutes there.
I just like how Aster talks back to Mason. Like, just deal with it.
Period. Queen.
Oh, I got signed out of my canvas and my student field, and I can't get back in.
Yeah, that sounds like a personal problem.
This is an A and B conversation.
I'm just
See your way out of it.
I'm just saying, like, it sounds.
So I did this backwards.
Talk with Ms. Larson.
Sign back in.
She's more tech. Like
No.
she knows.
I still don't know.
Can you do
I'm assuming it has to do with your Chromebook and stuff.
What is this?
Well,
Um,
Socialism.
I mean, you're listed.
you were
in,
trying to help me, but you were too.
I don't know how to log in.
Makes a lot of sense.
I can only do it through Hello ID. Because I don't know my camera.
All right. So Aster gave us our two-way table. R is getting a red card. RC is not a red card. J is a jack. JC is not a jack. We did do this one last time. What's the probability of J and R? This was also one of the ones we did last time. J and R. 2 out of? Thank you. J and R. The card is a jack and it's a red card. So a red jack, there are 2 red jacks out of 52 cards. What's the probability of getting a jack?
4 out of 52.
4 out of 52.
Slapjack.
So we want to find the probability of R given J. So if we go back up to the definition, P followed by P, excuse me, that's a B. B followed by A means that we want to find the probability event B happens given A did. So here when we have R followed by J, we want to find the probability the card is red.
I bet this one will pass.
Given the card is a jack. So what is the probability our card is red if we know it's a jack?
If we know it's a jack, 2 out of 4.
2 out of 4.
Wow, good job, dude.
Now, how did you get 2 out of 4, Colton?
Because there's 4 jacks. 2 of those jacks are
Okay,
red.
I think she called him Colton, actually.
So,
I think she did.
Colton and Trey together gave the correct explanation. If we know it's a jack, there's 4 cards we're looking at. Of those 4 cards, 2 of them are red. So our probability that it is red given it's a jack is 2 out of 4. Does anybody see how the 2 out of 4 relates to these 2 probabilities?
Yeah.
How?
Top.
The top. How would I get rid of the denominators? How would I get rid of them?
They cancel out.
How?
Because they're both 52.
Oh. Flip them, right? If I have 2 over 52, you guys don't need to write this part if you don't want to, but if I have 2 over 52 and I flipped the bottom, so I have 52 over 4, those 52s go away, right? And I get 2 over 4. What kind of arithmetic makes us flip a fraction? Division.
Yeah.
So, to find a conditional probability, we use division. If we want to find the probability of B happening given A happened, we take the probability of A and B happening and we divide it by the probability of A. So we had that probability of J and R happening was 2 out of 52. And so we would divide by the probability of J, which is 4 out of 52. But then we would, instead of divide, flip and multiply by the reciprocals so that we get the 2 out of 4. That's probability rule number 4. Notice the event that happens is the probability we divide by. So A happens, so I divide by A. So now we're going to use this rule for some example questions. Everybody okay if I flip?
Yes.
The Titanic. All right, 1912, the luxury liner Titanic, on its first voyage across the Atlantic, struck an iceberg and sank. Some passengers got off the ship in lifeboats. I really need to learn to proofread. Lifeboats, but many died. The two-way table gives information about adult passengers who lived and died by class of travel. Suppose we choose an adult passenger at random.
It's not like a full space.
So
Half space.
with adult, that's just the font I used. Sorry.
Oh, it is. It does.
All right, so part A, given that the person selected was in first class, what's the probability that he or she survived? So before we do any of this work, what's the first thing we should do with two-way tables?
I don't know.
Add them all in.
Add them all up.
I did it.
Oh, you already did it for me, Colton?
1,207.
Total.
What he said.
He just read off your phone. You're just going to let him do that?
Together.
All right, so it's
Shut up.
12. Hey.
Sorry.
Hey.
I didn't mean it.
All right, how many survived?
197.
No, total.
Oh, I don't know.
Out of the 1,207 passengers.
Hold on. I got this.
442.
442, how many died? I'm sorry, louder.
765.
Thank you. How many were in first class?
319.
How many were in second class? And third? Right.
319. That's 261.
Yes.
Like 697.
Yes. All right, so question A. Given that the person selected was in first class, what's the probability that he or she survived?
197 out of 1,207.
So that is part of it. So we want to find the probability that they survived
197 out of 317. 319.
given they were in first class. So using our conditional probability formula, that means we're going to take the probability they were in first class and survived divided by the probability they were in first class. Excuse me.
I thought it would just be like a whole thing.
So the 197 out of 1,207 that you said, Colton, that's the top fraction. They were in first class and survived. 197 out of 1,207. And then the bottom number,
Fraction and a fraction.
we have a fraction and a fraction.
Serious right now?
First class, total number of first class passengers was 319 out of 1,207. But see how our fractions within our fractions have the same denominators?
Yes.
I do see that.
So you just put a
So
two.
they would cancel each other out if we were to actually flip and multiply by the reciprocal. So like Mason said, we get 197 out of 319. Questions? Will you guys try that one, please? Don't forget to come in my jacket. Yes, I don't know why why he's still
It kind of looks like good on him.
Oh, it doesn't look
No,
good on
it
you,
looks
Maggie?
like-
huh?
It looks great on you too. I actually have the same jacket in my backpack, so I'm going to borrow it.
I don't know. My mom bought it for me years ago.
It's a good soccer jacket. Yeah.
Sweet.
How can you switch the two?
Honestly, it doesn't matter. Because if it's first and survive, that's going to be the same as survive.
You age me now, bro?
It's just, it changes the
So I have to divide by the given. But up here, it doesn't matter whether I write first and survive or survive and survive.
Well, that's what I'm saying. I don't know which way.
I miss having bass in my car.
You have
I wish that your bass was like. My bass was
We're
cool
told
as fuck.
bass
I had like a
survive.
sound
Well, when you
that
have a
was so
Here we
nice.
were told
It gets the job done. That was fun. Now I have a JBL one.
So it should be third class given, you survive.
She broke arm up.
Bro, you can tell it in my
Trey.
eyes.
Do you have the answer C?
Throw back to someone.
I think I do.
Is this yours?
Selected
No, it's not. Thank you though.
Doesn't feel like this is the last
Oh, it's
class.
cold.
Dude, I've been looking for this for like 2 months. Where was this?
On the
Right
ground.
here. I was gonna step on it, so I asked her if it was first.
Where'd it come from?
The ground.
The ground.
This is depressing, bro.
What?
This is depressing. Why are we depressed? Oh wait, no, it's not that depressing.
He thinks it's bad.
It's not depressing.
Okay, I'm still on this. I
I like the top one, but I don't like the bottom.
I guess. The beginning's kind of sad, but this part's good.
That's what I was saying.
You did it again.
I'm just gonna leave it. Give it a shot for another 2 months.
Oh God.
From the man above.
Okay, let's see.
Oh, we turned it down.
Sorry. You want it back up?
You guys get 151 out of 627.
I don't know how to do this.
You get what?
Well, she put it up there, but now that she's gone, there's no way of removing it.
I got 151 out of 627.
I got 151 out of 442.
I apologize.
She was in the corner down there. Please
Total of people
go.
that survived.
Yeah, but that would be the total for their class.
Why?
Because they're in the
Because I want you to pass.
if the person selected survived was
Oh,
that person in their class. So it's out of
Yeah,
all.
this one.
No, you're true. You're true.
But why it goes up?
If it's 442 and I was right, is it this?
If it's if
151
you're
out of
right.
667.
No.
I was right. It's one.
Is it out of 442?
It's 151 out of 442.
Yeah.
Why'd you guys psych me out like that?
442, where's it?
Yeah.
It's in
442. Oh, wait, what? How?
I have a
What the
knot in
hell,
my neck.
bro?
Okay, Nolan.
Why are you calling me Nolan?
Because Nolan always complains about his neck.
Nolan Geller?
Yeah.
No way you just compared me to him.
Dude.
Right?
That's
Wait,
not
is it the
funny.
soccer kid?
Yeah, he's like always so whiny.
He's so whiny.
He's so
A lot of people just
Are him and Booker in love yet? You know.
Alright.
Oh,
Will you
I
get
read
the
that.
sneakers out of it? Okay?
Never my ankle.
Aster's gonna show you guys
Remember my
how to
toe?
do this one.
Oh my. Dude, toe injuries are actually weird.
Right, I know. I had turf toe really bad.
What is?
Dude, I had like this little fracture in my toe. It hurt hella bad.
You've never heard of turf toe?
I know.
Yeah.
Turf toe, that
How's
sounds like
turf toe work?
Turfing your toe?
Yes.
How do you? What is it?
I got turf my
I'm gonna
Can you
eyeball.
explain
Explain it
turf
wrong.
toe to me, please?
Okay, in your foot, you have a bunch of little bones, right?
Yeah.
Under the big toe are two bones that are held together by ligaments connected to your toe, right? So if you stub your toe really hard, it
Hell no.
stretches the ligaments and it moves the bones so they're not in the correct place and you have extreme pain.
That's from your toe.
Uh-huh.
Why is it
It's
called
called
turf toe?
Because it happens
you, like,
to
drag it in the
athletes
Oh,
You
from stubbing
kick-
your toe repeatedly.
kicking the turf or
Dude,
football players.
Going to
use their
pass
toe.
and then hitting the turf too hard.
It's the
and
worst,
It's
like-
so embarrassing. Like
It
just
is.
It's embarrassing and it
sad.
hurts.
Yeah, it hurts. Your pass is shitty and it looks stupid.
Miss Widow, were you at the soccer field yesterday?
What soccer field?
North.
No.
Who was?
This little,
Are you guys playing Wednesday?
Yes.
Like this Wednesday?
I think so. They haven't put out the playoff schedule yet.
Okay,
because
let me
it's
know
playoffs.
let me know because I want to play, but I have work, so we'll get it covered.
Okay.
Because I do want to play, so
Okay. All right.
I wanna play
So
movie.
I saw a lot of 151s out of 627. That tells me you divided by the third class on the bottom. We are told that the person survived. So that's our given, which means that on the bottom we're going to divide by the total number who survived, which is 442.
Do you always have to write out this whole thing, or can you just write the answer?
I mean, so here's the issue. Notes, I don't really care a whole lot. On a test, if you give me 151 out of 627, I'm
be like, bruh.
right?
I'm gonna give you the
Like, where did it come from? But if you write out at least this part, I know that you either set it up right and read the numbers wrong, or you set up the formula incorrectly. It does change how I grade.
I can't remember the formula, but I know the answer. You know?
You gotta
Picking up what I'm
divide
picking up
by the what's given, and then the top is both of them together.
Shut up.
All right, so we're gonna look at a similar type of question, but we're gonna add a step where we have to explain what our answer means. So, the following two-way table describes the 595 students who responded to a school survey about eating breakfast. Suppose we select a student at random. We're going to consider events B, they eat breakfast regularly, and M, they are male.
Have a peel.
This time I filled in all the totals for you. So we have 320 who responded were male, 275 were female, 300 eat breakfast regularly, and 295 don't eat breakfast regularly. So we want to find the probability that they eat breakfast regularly given they're male. So the probability they eat breakfast regularly given male comes from the probability they are male and eat breakfast regularly divided by the probability they're male.
No, for real. That looks like BLM.
Probability that they're male and eat breakfast is 190 out of 595.
She just put it on. And I get bleach in my t-shirt. I'm gonna feel like an asshole.
Probability that they're male, that would be 320 out of 595. And then conveniently, the denominators cancel each other out. So we end up with 190 over 320.
Why don't you just skip that step and just do 190 out of 320?
Yeah.
I
Because
just asked that.
Because in a minute we're not going to read it from a two-way table, and you need to use the whole probability because sometimes they may not cancel out.
Okay,
What happens if they don't
Now.
cancel out?
We'll look at that in a second.
Wait, South Korea knocked out Uruguay?
Yeah.
Oh, Uruguay.
Told you were today.
We're going to explain what this value means. Now, we need to change this to a decimal. Up above, I didn't change it to a decimal, but here we're going to because it makes it easier to explain. So 190 divided by 320, 0.59375. So we're going to write a sentence that tells us what this value means. We were told that they're male, so given the student is male, we would expect that they eat breakfast regularly.
Bro.
Hey Colton,
What?
remember that promise you made me?
Yeah.
Can you keep it?
You promise you would.
I'm gonna change the decimal to a percent, so they eat breakfast regularly 59.375% of the time. You guys are going to do B. You're going to find the probability the student is male given they eat breakfast regularly, and then write a sentence to explain, please.
Wait, what? Isn't this the same thing as switch?
Yes, it is the same thing, but just switched.
Or is it not just 320 over 190?
No.
No.
Now it's PMB.
Wait, what does the straight line mean again?
Given.
Then breakfast.
Oh shit, I haven't heard the song.
Here we go.
What?
I haven't heard the song in a minute.
You hate it?
I haven't heard the song in a minute.
Oh, thank you. My dad loves this song.
Why is it not?
That's not a sentence.
I don't know. So did my manager at Wichita.
This reminds me of One Direction.
What?
This reminds me of One Direction.
No. Oh my god.
Wait, is it not 320 over 13?
No,
300.
Bruh. What is it? What is it?
Is it 190 over 3?
Goodness.
no, we just did 190 over
Oh.
320.
So it's 320 over.
No.
Oh my god. Yeah, shit.
190
Kept my fault.
over 295.
Okay.
No. 5. No. I'm just gonna wait. No, Colton. I don't know.
Theoretically.
Katiara is going to put this one on the board for you guys.
So 190 divided by 320. Said this. Yes, it does get long.
I'm just gonna shut up.
I know what it is.
Yeah. No. That's what I'm gonna do. Too much. Do it.
Call my mom.
Why not?
I wrote it out. I said give it
Brooke
Becky
made it.
his mail, but
Swear.
it's good they should give her
We all know it was
This whole table, you're more likely probability wise.
No, I saw it's usually old people. All right.
That's what I said.
The top. No, that's not.
No, he actually did say that.
190 is still the same. This time, the given is breakfast, so we're dividing by the total number of people who eat breakfast regularly, so 300. Then Kitiara wrote it in a sentence. Given the student eats breakfast regularly, we would expect them to be male 63.33% of the time. Any questions before we flip our paper over?
Miss Little,
Yes.
you know that movie that you and Bellsberg watched it? It's called Jexy or whatever.
Yes.
And he suggests I watched it, and I watched it like yesterday, and it was so horrifically inappropriate. I was like shocked.
Is it worth it? I mean,
He's got great
oh yeah, there were some inappropriate parts. Yeah. Do you think?
The phone.
Do you
I was watching,
you-
and my little brother walked in, and I was like,
Do you think that we don't watch like inappropriate
I don't know your
movies?
teachers, like.
Oh, so we're not allowed to be humans?
No.
No.
Oh, okay.
Teachers are only
What?
educational.
Yeah, we watched Yellowstone. I did not enjoy Yellowstone.
Everyone says my dad looks like Rip.
Bellsberg liked Yellowstone. I did not enjoy it as much. Yes.
So some of Yellowstone filmed in Park City.
This whole personality.
And my dad built one of the houses in Yellowstone.
That is really cool. Yeah. All right. Next example. Tax returns. So we have the distribution of the adjusted gross income. It's given in thousands of dollars, so I didn't have to put all the extra zeros. Reported on individual federal income tax returns in a recent year. So across the top, we have the income less than 25,000, 25,000 to 49,000, 50 to 99,000, 100 to 499,000, and greater than or equal to 500,000. Probabilities are listed below. We want to find the probability that a randomly chosen return shows an adjusted gross. Seriously, I did really bad with my right spelling. Sorry. Income of 50,000 or more. I don't know what happened to me.
No, they're not. How did you do that?
I don't know, okay?
This was my #1 played song all year. T-Power was.
All right, so
I'm gonna give her one of those grabby things that we use when we're handicapped.
50,000 or more. That means that they could fall in the 50 to 99, 100 to 499, or the 500 plus. So we're going to take those three probabilities and add them together. And we get 0.321. So the probability that the return had an adjusted gross income of 50,000 or more is 0.321. Any questions? All right. B, given that a return shows an income of at least 50,000? What is the conditional probability that the income is at least 100,000?
What?
Okay, that doesn't.
Yeah, I get it.
Yeah.
What is the probability that I pick an income that shows 100,000 or more, given I know the income is 50,000 or more?
248 plus 0321.
Literally.
So on top is the probability that it is 50,000 or more and 100,000 or more, divided by the given, which is the probability of 50,000 or more. The probability of 50,000 or more is what we found in part A. A lot of conditional probability questions are broken up this way. They'll have you find one of them, and then they'll ask you to find the conditional. So we have 0.321 on the bottom. Now the top is a little weird because if it's 50,000 or more and 100,000 or more, really it's just 100,000 or more, right? Because I can't be 100,000 or more if it's like 60.
Yeah.
So for this top one, I'm only going to be looking at the last two. And that's a simple thing I can add in my head. It'd be 0.106 on top. And then I need my calculator, 0.106 divided by 0.321. So we get 0.33. Questions? All right, we're going to look at another one. Mac or PC? No, I'm not. I don't want to know. A recent census at a major university revealed that 40% of its students mainly used Mac computers. The rest mainly used PCs. At the time of the census, 67% of the school students were undergraduates. The rest were graduate students. In the census, 23% of the respondents were graduate students who said that they use PCs as their primary computers. Suppose we select a student at random from among those who were part of the census and learn that the student mainly uses a PC. Find the probability that this person is a graduate student. Told you they're not always given in tables, Colton.
Straight up on my mama.
That's despicable.
Suppose we select a student at random and learn that they mainly use a PC. That is our given condition right there. They're a PC user. If we know they're a PC user, what's the probability that they're a graduate student? So using our conditional probability formula, we would take the probability that they use a PC and are a graduate, divided by the probability they use a PC. So, probability they use a PC and are a graduate student.
Are you a graduate student?
Doesn't it just say 23% of the respondents were graduate students?
I genuinely am so confused.
23% are graduate students who said that they use PCs as their primary computers. So the top is 0.23. What's the probability that a student uses PC?
Oh.
.60. That one's not given directly. We're told 40% mainly use Macs and the rest mainly use PCs. So that means we have 0.6 on the bottom, which when we divide that, 0.23 divided by 0.6, which would be 0.38333 forever. Questions?
Wait, what's 6?
The 60. So the probability they use a PC. So the very first number we're told is 40% mainly use Mac computers. The rest mainly use PCs. So that means 60% are PC users. Any other questions?
I'm ready.
Nope. All right. Exit task.
I was like, okay. Cool.